Hello friends, I welcome you in lecture number 8 on graph theory. In this lecture, we are going to discuss about one special graph known as complete graph. We will understand the definition of complete graph with examples. So complete graph is a simple graph. Simple graph means there are no parallel edges and loops in a graph. A simple graph in which every pair of distinct vertices, say Vi and Vj, if Vi and Vj are distinct vertices, then they must be joined by an edge. If every pair of distinct vertices is joined by an edge in a graph, then the graph is called complete graph. So if I consider two vertices, then I have to join V1 and V2. So this is complete graph with two vertices. Suppose I have three vertices, then to draw the complete graph, I have to join every pair of distinct vertices. So V1 and V2 must be joined by an edge, V1 and V3 must be joined by an edge, and V2 and V3 must be joined by an edge. Similarly, we can draw a complete graph on four vertices denoted by V1, V2, V3, V4. So this graph is complete if every pair of distinct vertices is joined by an edge. In other words, every vertex is joined by an edge with remaining vertices. Suppose I consider V1, then V1 must be joined with V2, V3 and V4 by an edge, or we can say that every vertex is adjacent to remaining vertices. V1 is adjacent to V2, V3 and V4 because V1 is joined by an edge with V2, V3 and V4, and that must be true for each vertex. So for V2 also we have to join it with three vertices V1, V4, V3 and same thing for V3. So we can see here, if we take any two vertices in this graph, then they are joined by an edge, and therefore this is a complete graph on four vertices. If we have only one vertex, then it is called complete graph on one vertex. So in general, if we have n vertices, then a complete graph on n vertices is denoted by k suffix n. So if I have only one vertex, I will denote this graph by k1. If I have two vertices, graph will be denoted by k2. Complete graph on three vertices will be denoted by k3. Complete graph on four vertices will be denoted by k4. Similarly, we can draw a complete graph on five vertices also. Suppose I consider five vertices, 1, 2, 3, 4 and 5. So this graph is complete if every vertex is joined by an edge with remaining vertices. So I am joining this vertex first with all remaining vertices. Then I will join this vertex with all remaining vertices. I will consider one by one. Then this vertex is to be joined with remaining vertices. So I will join these two and these two. Similarly, this is to be joined and I have to join these two. So now we can see, if we take any two vertices, then they are joined by an edge. So this is the complete graph on five vertices. We have to take care that every vertex is joined by an edge with four vertices. Now if you observe that in a complete graph, every vertex must be joined by an edge with remaining vertices. So here I have five vertices in K5, n equal to 5. So each vertex must be joined with remaining n minus 1, that is 4 vertices, or there are 4 edges which are incident with that vertex. What is meaning of this? that there are 4 edges incident with that vertex, or for every vertex there are 4 edges ending at that vertex, or there are 4 edges meeting at a vertex in a complete graph. That means degree of any vertex in this graph is n minus 1, that is 4. So we must check that 4 edges are meeting at a vertex in a complete graph. For this we can check 1, 2, 3 and 4. Similarly 1, 2, 3 and 4. 1, 2, 3 and 4 edges. 1, 2, 3 and 4 here also. 1, 2, 3 and 4. So this is a cross check. If you are drawing a complete graph on n vertices, then you can verify that degree of every vertex is n minus 1. Here n is 5, so degree of every vertex is 4, so that you do not miss any pair of vertices to join them by an edge. Similarly, we can draw a complete graph on 6 vertices also. So this is very easy to understand. A complete graph is a simple graph in which every pair of distinct vertices is joined by an edge. They can ask you to write down the definition. A simple graph in which every pair of distinct vertices is joined by an edge is called a complete graph. The complete graph on n vertices is denoted by Kn. You can write equivalent definition also. A simple graph is said to be complete if every node is adjacent to all other nodes of the graph. That means every node is joined by an edge to all other nodes of the graph. And our one observation is that if there are n vertices in a complete graph, then degree of each vertex is n minus 1, because every node is joined by an edge with n minus 1 nodes. Therefore there are n minus 1 edges meeting or ending at a particular node. Therefore degree of each vertex in a complete graph is n minus 1. We can draw a complete graph on 6 vertices also. For that I have to consider 6 vertices: 1, 2, 3, 4, 5 and 6. Now I have to join every vertex to remaining vertices by an edge. Here I am taking 6 vertices, so I have to take care that every vertex is joined with remaining 5 vertices, or there are 5 edges at every vertex meeting or ending at every vertex. So 1, 2, 3, 4 and 5. So there are 5 edges at this vertex. Suppose we denote vertices by V1, V2, V3, V4, so V5 and V6. Now we check for V2. There must be 5 edges meeting or ending at V2. So 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5 edges are meeting or ending at V2. Then for V3 we have 1, 2, then 3, 4 and 5 edges meeting or ending at V3. For V4, 1, 2, 3, 4 and 5 edges meeting or ending at V4. For V5 there are already 4 edges: 1, 2, 3, 4. So I have to join V4 with V5 with V6, and I have constructed a complete graph on 6 vertices, which we denote by K suffix 6. So in this way you can draw complete graph on n vertices. You have to take care that every vertex is joined with remaining n minus 1 vertices by an edge. That means degree of every vertex is n minus 1 if there are n vertices in a graph. Now we can prove this result on the complete graph. We can prove that the number of edges in a complete graph on n vertices is n into n minus 1 divided by 2. We can check here that here n is 6, so n into n minus 1 by 2, that is 6 into 5 divided by 2, and that turns out to be 15. So there must be 15 edges here, that we can check. 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12, 13, 14 and 15. So if there are n vertices in a complete graph, then the number of edges denoted by E is always n into n minus 1 by 2. So this is another cross check to verify whether your complete graph is properly drawn or constructed. Now we can prove this result. It is easy to prove this result. We have to use that handshaking theorem. We know that in any graph, if we sum all the degrees, or if we take the sum of degrees of all the vertices, then it is equal to twice the number of edges, where this V is the vertex set or set of vertices of given graph, and this result is known as handshaking theorem. Another name for this result is first theorem of graph theory. Remember, this result is also known as first theorem of graph theory, which says that sum of degrees of all the vertices in a graph is equal to twice the number of edges. So we can use this result here to prove that number of edges in a complete graph on n vertices is n into n minus 1 by 2. So first I write that suppose G equal to V E be a complete graph on n vertices, or we know that if we have complete graph on n vertices, it is denoted by k suffix n. Now if V is any vertex in a complete graph, then clearly V is adjacent to remaining n minus 1 vertices, remaining n minus 1 nodes or vertices, and therefore there are n minus 1 edges meeting or ending at V. That means degree of V is n minus 1. So degree of each vertex in a complete graph on n vertices is n minus 1. Now we can use handshaking theorem or first theorem of graph theory by first theorem of graph theory. If we take sum of degrees of vertices, sum of degrees of all the vertices, then it is equal to 2 times number of edges, where E equal to number of edges. This means if I have n vertices, and because graph is complete, I know that degree of every vertex is n minus 1, and we know that we have n vertices. So here we have to add n minus 1 n times, because there are n vertices and degree of each vertex is n minus 1. We have n times n minus 1 in the summation, and that is equal to 2 into E. And because we are adding n minus 1 n times, this turns out to be n times n minus 1 equal to 2 times number of edges. Therefore, E equal to n into n minus 1 divided by 2. That means the number of edges in a complete graph Kn is n into n minus 1 by 2. So this is very nice result. Using this result, you can check whether your graph constructed is complete or not. So this is all about this session. In this session, we have discussed the definition of complete graph. A complete graph is a simple graph in which every vertex is joined by an edge to all other vertices. And if we have n vertices in a complete graph, it is denoted by Kn. And if we consider any vertex in Kn, degree of that vertex is n minus 1 and number of edges are n into n minus 1 divided by 2. So I stop here and we will continue with this type of concepts of graph theory in upcoming lectures. Thanks for watching.